Hello there. In this lesson, we are going to show you a step-by-step guide on how to evaluate a design problem. The problem we are going to look at is the process of producing methanol from carbon dioxide and hydrogen. We have received this assignment problem from one of the learners who are registered on tutu.me Open College. Remember that as a registered learner on tutu.me Open College, you have many tools to help you with your studies. One of these tools is Assign Assist, which will assist you by guiding you through your assignments. Please note that we will not do assignments for you. Assign Assist only guides you. You have to do assignments yourself. Okay then. The problem we are given is posted in the link given below. Please click the link to download the problem statement if you have not already done so, and please take time to read through it to understand the requirements. The problem states that byproducts of carbon dioxide and hydrogen from a petroleum refinery are reacted in a continuous stirred tank reactor, also known as a CSTR, to produce methanol and water. The reaction is given here. We are further told that the system uses an 800-liter CSTR conversion reactor operating at 35 degrees Celsius and a pressure of 1 atmosphere for a first-order reaction with reaction rate 4 per minute. Assuming complete conversion of the reactants, the liquid product is pumped out of the CSTR to a distillation column at a flow rate of 53 cubic meters per using a centrifugal pump. Upon reaching the distillation column, the fluid is heated to 50 degrees Celsius using a single-pass shell and tube heat exchanger, where the shell side temperature changes from 110 degrees Celsius to 90 degrees Celsius. The heat exchanger is a countercurrent flow arrangement. The distillation column is maintained at a pressure of 250 kilopascals and produces an overhead product purity of not less than 90% methanol and not more than 10% methanol in the bottom stream. Additional information on the piping layout and heat exchanger specifications is given in the tables provided. Moving forward, we are required to evaluate this design problem by criticizing it by following the given 6 questions. The first question is concerning the reaction conditions. We are to use available literature sources to evaluate why this reaction cannot occur at a temperature of 35 degrees Celsius and a pressure of 1 atmosphere. Also, we have to suggest more reasonable conditions, that is, the temperature and pressure at which this reaction is likely to occur. We can use Gibbs free energy calculations from the second law of thermodynamics to determine the temperature and pressure ranges favoring this reaction. In the second question, you are being asked to consider the reaction conditions that you have suggested in question 1, at which this reaction is likely to occur. Use your knowledge of chemical reactors to answer the following questions. Is it possible to use a CSTR for this reaction? Can you react gases in a CSTR? If you can, how? Will the product be liquid at the conditions that you have suggested? If you cannot use a CSTR, which reactor can you use? Moving on to the third question, you are asked to criticize the given reaction rate and reactor specifications. You have been given the rate of reaction as a first-order rate of 4 per minute. Does this reaction look like a first-order reaction? From your knowledge of reaction engineering, what order is this reaction likely to be with respect to each reactant? You have also been given the reactor volume and, in addition, it is specified that the reaction goes to completion. Why is this part of the problem overspecified? Support your answer with reaction engineering knowledge and cite textbooks and literature references. The fourth question focuses on the shell and tube heat exchanger specifications. Stream, You have been given the flow rate, the inlet temperature, and the outlet temperature. Also, you have been given the inlet temperature and outlet temperature of the heating medium. The heating medium is not specified. Is it steam? Is it hot oil? We don't know. The heating stream flow rate is not given. We have been told that the heating medium is on the shell side of the heat exchanger. There is more information given in the data table. You are being asked to use your knowledge of heat exchanger design to critique if the given information is too much, too little, or just enough to do the heat exchanger calculations. Support your answer with heat exchanger design equations. In question number 5, you are required to look at the given information for distillation. Is it possible to do the distillation calculations to produce streams of required purity and complete the distillation column specifications? Support your answers with equations and textbook references or literature references. In the 6th question, you need to look at the pump information given and answer the following. Can you do the pump sizing and specification calculations? Where is the pump located? Are there any height specifications or considerations? Can you do the NPSH calculations and check if the pump is positioned accordingly to prevent cavitation? Support your answers with equations and textbook references or literature references. In the second part of the question, you are required to use your knowledge gained in part 1 to propose and solve a more reasonably defined design problem with better specifications. Used to simulate the process flow sheet. By answering the questions in this project, you will be demonstrating competence in the following graduate attributes. The graduate attribute of engineering design, by first showing the ability to evaluate a design problem, and by showing creativity finding alternative designs, if the presented design problem does not meet the minimum required specifications or does not make engineering design sense. Secondly, you will further demonstrate competence in graduate attribute of being able to use engineering methods, skills, tools, including information technology. This will be demonstrated by your ability to use ChemCAT computer simulation to evaluate the given design and propose the new design and develop a solution for this new design. And lastly, you will further demonstrate competence in the graduate attribute of independent learning ability. This will be demonstrated by your ability to use available knowledge resources to evaluate and critique the given design problem. Furthermore, using supporting references from textbooks and engineering literature to propose a new improved and sensible design. This concludes the first session of the project. In the next sessions, we will take you through a step-by-step guide on how to answer the 6 questions in a manner that shows that you have competence in the associated graduate attributes. And lastly, we will present a sensible design problem and a simulation of your proposed design.
Thank you very much for studying with Tutor.me Open College. Please click subscribe so that you are kept updated with new learning material as it is being updated. If you like this video, also, please click like so that the video is recommended to other learners such as yourself.